Hi, now we are going to see about CDMA technique. Code division multiple access, also called spread spectrum communication, differs from FDMA and TDMA because it allows users to literally transmit on top of each other. This feature has allowed CDMA to gain attention in commercial satellite communication. It was originally developed for use in military satellite communication where its inherent anti-jam and security features are highly desirable. CDMA was adopted in cellular mobile telephone as an interference-tolerant communication technology that increases capacity above analog systems. It has not been proven that CDMA is universally superior as this depends on the specific requirements. For example, an effective CDMA system requires contiguous bandwidth equal to at least the spread bandwidth. Two forms of CDMA are applied in practice. The first one is direct sequence spread spectrum and the second is frequency hopping spread spectrum. Frequency hopping spread spectrum has been used by the Omnitrax and Utiltrax mobile messaging system for more than 10 years now, and only recently has it been applied in the consumer's commercial world in the form of the Bluetooth wireless LAN standard. However, most CDMA applications over commercial satellites employ direct sequence spread spectrum. Consider the following summary of the features of spread spectrum technology, whether it is a direct sequence spread spectrum or frequency hopping spread spectrum. Simplified multiple access, which means no requirement for coordination among users. Selective addressing capability if each station has a unique chip code sequence, which provides authentication. Alternatively, a common code may still perform the CDMA function adequately since the probability of stations happening to be in synchronization is approximately 1 by n. Relatively security from eavesdroppers, the low spread power and relatively fast direct sequence modulation by the pseudo random code make detection difficult. Interference rejection is the spread spectrum receiver treats the other direct sequence spread spectrum as thermal noise and suppress the narrowband interference. A typical CDMA receiver must carry out the following functions in order to acquire the signal, maintain synchronization and reliably recover the data. The synchronization, which the incoming code through the technique of correlation detection, despreading of the carrier, tracking the spreading signal to maintain synchronization, demodulation of the basic data stream, time and bit detection, forward error correction to reduce the effective error rate. The first three functions are needed to extract the signal from the clutter of noise and other signals. The process of demodulation, bit timing and detection, and forward error correction are standard for a digital receiver regardless of the multiple access method. The next one is frequency division multiple access. Nearly every terrestrial or satellite radio communication system employs some form of FDMA to divide up the available spectrum. The areas where it has the strongest hold are in single channel per carrier, intermediate data rate links, voice telephone systems, VSAT data networks, and some video networking schemes. Any of these networks can operate alongside other networks within the same transponder. User need only acquire the amount of bandwidth and power that they require to provide the needed connectivity and throughput. Also, equipment operation is simplified since no coordination is needed other than assuring that each earth station remains on its assigned frequency and that power level are properly regulated. However, intermodulation distortion present with multiple carriers in the same amplifier must be assessed and managed as well. The satellite operator divides up the power and bandwidth of the transponder and sells off the capacity in attractively priced segments. Users pay for only the amount that they need. If the requirement increases, additional FDMA channels can be purchased. The IMD that FDMA produces within a transponder must be accounted for in the link budget. Otherwise, service quality and capacity will degrade rapidly as user attempts to compensate by increasing uplink power further. The big advantage, however, is that each earth station has its own independent frequency on which to operate. A bandwidth segment can be assigned to a particular network of users who subdivided the spectrum further based on individual needs. Another feature is to assign carrier frequencies when they are needed to satisfy a traffic requirement. This is the general class of demand assigned network, also called demand assigned multiple access. In general, the DAMA can be applied to all three multiple access schemes previously described. However, the term is the most often associated with FDMA. Therefore, the summary is given as the bottom line in multiple access is that there is no single system that provides a universal answer. FDMA, TDMA, and CDMA will each continue to have a place in building the applications of the future. They can all be applied to digital communications and satellite links. When a specific application is considered, it is recommended to perform the comparison to make the most intelligent section. Thank you.